Hello all. Today we are going to talk about how we work with Newton's law, second law. Right? So, uh, if you can recall what is second law, so it is nothing but net force acting on a body is equal to mass time into acceleration. Okay. Now, uh, these are the some steps you can go through it, and we'll examine each step as we take some examples. Okay. So first step says decide the system. Now system can be one block, one pulley, or two blocks connected with a string, three blocks, and so on. Okay, system can be very simple to very complicated. Now once we decide the system, the second step is what are the forces acting on the system. So in the second step, we decide what are the forces acting on the system, and then we represent in a free body diagram. Okay, and generally we deal with two-dimensional motion. So we'll select x and y axis, and then we will use net force along x-axis is equal to mass time acceleration along that axis, and net force along y-axis is equal to mass time acceleration along this. Now I want to explain why this two equation comes, because if you are dealing with Newton's second law, then it says that net force, fine, is equal to mass time acceleration. Now if we resolve it, this one, in two dimension, then along x-axis we can write this equation, and along y-axis we can write this. So vector 1 equation in two dimension will be equivalent of this two expression. Now we'll talk about it. So let us take the simplest example to start with. Let us say we have a block here, and let us say we are there is no friction here. This is smooth. Okay, unless mentioned, we'll talk about the smooth surfaces, so no friction, and its mass is m, this block. So suppose if I apply a force in this direction, let us say F, and I ask you what is the acceleration considering there is no friction, then it's very easy for you to say that you have decided your system this. You might say that uh, so this is my system. Second, what are the forces acting on the system? So you will draw uh, mg, and then the ground will support it with some force, let us say r. So these are the forces acting on the system. Now we choose this to be our x-axis and this to be our y-axis. Now we all can agree on this, that as this force will act, the acceleration will be in this direction, right? Acceleration. So there will be no motion along y direction. So along x direction, Newton's first law of second law will read net force acting, that is only F, and that is equal to m into a. Fine. And along y direction, there is no motion, so normal force will be equal to m into g. So it turns out that from here we can find out acceleration of this block will be F by m. Fine. Now moving on, suppose we have the same example, but let us say we are dealing with the same example, but in this case uh, this is the block, this is the surface, and let us say in this case the force is acting along this direction. So and this force is making an angle theta. This is a force, and let us say this is rough surface. Now the question is, find the acceleration of the system. Fine. Now again we'll do the same thing. We'll identify this block to be our system, and then we'll draw the free body diagram. Fine. So if I draw free body diagram of this block, so mg will act in this direction, normal force will act in this direction. If you resolve this force, then you will find f cos theta will act in this direction, and this component will be f sin theta. So f sin theta will act in this direction. And since the surface is rough, then we all can say that friction will act in this direction. Now, so again, there is no motion along y direction. So along x direction, if I use Newton's second law, net force acting, you can see F cos theta is acting in this direction and F friction is acting in this direction. So net force will be F cos theta minus friction equal to mass time acceleration. Right? So acceleration of the block is going to be F cos theta minus F. What is about y direction? So you will see that along y direction, if you see the diagram, then R will be equal to mg plus f sin theta. Right. Now, these are the simplest examples. Okay. Now let us move on to our next example. Now in this example, let us say, okay, this force is some number. Let us give number 10 Newton. This is 1 kg block, and this is 10 kg block. The question is, find the acceleration. Let us say in the first part we have to find the acceleration of the system, and let us say this surface is smooth. Okay. Now, what is the acceleration of the system? Now you can see this 1 kg, 10 kg combined will give you 11 kg. So as this force will act, we all can agree on the fact that this entire block will move in this direction. So acceleration will be in this direction. Fine. Can we consider A plus B to be our system? So if I consider A plus B to be my system, can we do that? The answer is yes. The only restriction in the system is that all parts of the system should have same acceleration. So you all will agree that if A goes, this goes by some amount, let us say x, B will also move by the same amount x, right? No? So A plus B can be called as a system, and the reason being both have same acceleration. Now, if we consider A plus B to be our system, then it turns out that we have one block of 11 kg, and along this force 10 Newton is acting, and what other forces will act? Downward will be your m into g. So I'm writing 11g, mass is 11 and this is g, and upward will be normal reaction force r. So if I apply laws of motion along x direction, along x, I can write net force along x is equal to mass time acceleration. So acceleration will be, F is given to be 10, mass is 11. So 10 by 11, whatever comes, it will be, it is something like 0.9 meter per second. This is the acceleration. Now let us go one step further. Suppose in the same question you have to calculate the contact force between A and B. So next what we are going to do, let us say second part, let us say you have to calculate contact force between A. Now how we deal with that? Now it turns out that it's very easy. So what we are going to do, if I represent the system, let us say A, this is the block A, right? So we know that the force is acting on this. Now, what will be the contact force due to B on A? So we all know that the contact force on A due to B will be in this direction. And let us write it to be R. Fine. Now acceleration of A is in this direction. So now if I apply Newton's second law for A, what will be the equation? So along x direction, I can write F minus R will be equal to mass of A, whatever is that, into acceleration. Now remember, when I'm calculating contact force between A and B, now this A is my system. Okay, this is my system now. So once I decide the system, I label all the forces acting on it. Fine. Now this will be the equation. Now we have to find R, right? So we know that, we know what is acceleration, that is 0.9. We know this is 1 kg. We know what is this, and that is going to be 10, right? So if you substitute this, you can calculate what is the value of contact force between A and B. Now, if the question also says that what will be the contact force on B, so we all know that if I draw B to be, this is B, and let us say this is A, so let us draw them separately. So we all know that if B is giving a force in this direction, then the contact force on this will be in this direction, okay, which will have same magnitude but opposite direction because of Newton's third law, because this applies a force R in this direction, so this will apply the force R in this direction. Fine. So that will be the same answer. Fine. Now moving on. Now if you see this question, let us say we have to find this mass is given, let us say MA, and this mass is given MB. Let us say for the time being MA is greater than MB. The question first part is calculate the acceleration of the system. Right? And it is also mentioned that there is no mass in the string, and this pulley does not rotate. Fine. So this string can slide over the pulley. Fine. You have to calculate acceleration of the masses. Now, we all can agree on this fact that suppose this goes by some amount x, this will also go by the same amount x in this direction. The reason being is that the string length is constant. So if this goes down by some unit, this has to go up by same unit. So for that reason, we can conclude that the system acceleration, A acceleration will be downward and B acceleration will be upward. Same. Now, here one thing we have to understand that we can't treat A plus B to be our system. A plus B cannot be taken as a system. Okay, what is the reason? Because the restriction on selecting system was that all the parts of the system should have identical acceleration. Now acceleration is a vector quantity. It has both magnitude and direction. So it turns out that this A and B have same acceleration in magnitude wise, but direction is different. So A plus B cannot be considered as a system here, right? So we have to deal with A and B separately. Now, let us draw the forces acting on the selected system. So let us concentrate. So we all know that if I take A, so tension will be upward here and force of gravity is downward, which is this. If I take B, tension will be upward and force of gravity will be downward. Now, let us talk about A first, right? Okay. Now, if I only study A, and of course we are dealing with this axis, so this is, you can say this along y-axis, you can say, so this is the axis we are interested in studying. Okay, the motion is along this direction only. So let us talk about A. Now, if I apply Newton's second law to A, net force acting on it is equal to mass times its acceleration. So you can see it's going downward. So net force will be this minus this, right? So M A G minus T will be equal to M. This will be the equation of motion for A, right? Same way, if we write it for B, B is going upward. So T minus M B G right. Now, if we want to calculate acceleration, then it's very easy. Now, what we can do, we can equate it. So from here, I can write T will be equal to MBA plus MBG, right? So if I substitute this in this equation, let us say equation 1, then we will get, so putting this T here, right? So we will get MAG minus MVA equal to MVA, which will give, we can take this A common, so this will give A A This will give you, this is common, this is common here. So this will be, so acceleration will be, so this is going to be our answer of acceleration. Okay. Uh, Now, same way, what we can do, we can find the tension in the string also. What you have to do, you have to put this A back here. Let us say, so this A can be substituted here, and you can rearrange it, and you can calculate what is the value of tension. Okay, that I'm keeping you to find it out. So these are two simplest example to start the Newton's second law of motion. We'll see some more example in our coming classes. Thank you.